Welcome to the demo and walkthrough for the Cisco Nexus plugin using the OpenStack Grizzly release on the Cisco OpenStack installer setup, and we're on the Grizzly G.1 release as it is applied to the Cisco environment. So topologically, let's take a look at kind of what our setup is here. And what we have here is we've got a Nexus top-of-rack switch or access layer switch that is connected via trunk links to our data center aggregation layer switches. We've got two nodes, our OpenStack control server and our OpenStack compute server. So what we've done ahead of time is we have configured all of the SVIs with all of the trunk links for our VLAN ranges. VLAN 13 in our example is our management VLAN that is being used, to do Pixie boot and all of our Puppet agent to Puppet master and manifest and so forth. All traverse this link, and then obviously we manage the OpenStack environment via this link. Then we've got in red, indicating that we're using trunk links on all of those items in red. We've got these VLANs 500 through 600, which are going to be mapped and used for our provider networks that our virtual machine or instances are going to use to get out to the rest of our data center and then off to the internet. So a couple of important things here is, one, we're not walking through the configurations of all of these. This is very, very basic trunk link type things, switchboard mode trunk and your trunk allowed statements and so forth, and all of that stuff has been configured. We will take a look at E1/8 here, which is what the physical interface is that connects to our compute server that we're going to be testing against. And we will take a look at this at a few times through our test, because this is what's going to be automatically configured for these VLANs as we attach instances to them, okay? Now, the other part here is if you have a setup like I do, which is where my DHCP agents are actually hosted on my control server, then you need to either have a dedicated interface or a trunk link with an interface for these VLANs where the DHCP agent can actually have L2 connectivity through your top-of-rack switches and trunk links into your compute nodes, because we need to make sure that the DHCP agent has L2 adjacency, if you will, to the instances that are running on each of these networks. Okay, so this is a trunk link for 500 through 600. This is a trunk link that will be automatically configured by the plugin through 500 through 600, and then obviously we need those trunk links up to our L3 termination points. All right. So that's what it looks like for us from a topological perspective, okay? Now again, I mentioned this is using the Cisco OpenStack installer as a means to deploy this entire environment. So that means in the Puppet world that we're dealing with manifest. And so you will see, and I'll show you a link later on, that as a part of our site.pp file that we provide you as an example, there's a section in there that you need to modify for your OVS and your plugin configurations. Now I've stripped all of the rest of the site.pp file out, and I'm just showing you what we're using for this topological example, okay? So again, a reminder here, ETH0 in our environment we're defining as our public interface. I'm calling that the management network in the diagram. And then ETH1 is our external interface. I'm calling that the data network, okay? And then we get into our OVS configuration. So the VLAN ranges, we're going to associate this user-defined parameter, FizzNet1, you can name it whatever, and then our VLAN ranges are 500 through 600 in this example. Then in our bridge uplinks, we're tying a bridge, BRETH1, again, we came up with that name, you can name it whatever you want. BRETH1 is mapped to the physical adapter on our compute server, ETH1. Then our bridge mappings, we're just mapping our FizzNet1 to BRETH1. Okay, and so this is kind of how this flows. We will attach instances to an integration bridge that is connecting to FizzNet1 as an identifier, and we'll see what that looks like later on. And then FizzNet1 is mapped to BRETH1. BRETH1 knows that the uplink that it's attached to is the physical adapter ETH1, and then ETH1 is connected to our top-of-rack switch. Okay, so that's how that flow goes. Now, the Quantum Core plugin is identified as Cisco. The vSwitch plugin is OVS. This could also be the Nexus 1000V vSwitch plugin. And the Cisco Nexus plugin is just Nexus. Then we get into our Nexus config. This is the IP address of the actual Nexus top of rack switch that you're connecting to. This is the server identifier that we're attaching this to, compute server 01, compute server 01, and then the physical interface on the Nexus that it's connected for, okay, or connected to. And then I'll show you a document at the end where you can see multiple examples of multiple interfaces and multiple switches, okay. Nexus credentials, we've identified here. This is the IP address, the username, password, okay. And then the tenant network type we're identifying as VLAN. So let's kind of take a look at what our situation is here. So right now, there is nothing configured network-wise as it relates to quantum inside of our environment. And we can actually go over here, take a look at our network topology in the dashboard. There's nothing defined there, no instances, nothing. Okay, we've already done the access networks and the images and the the key pairs and all that other stuff. So what we want to do here is we want to take a look at real quick on our switch the interface that is in question here. What have we done from a configuration perspective? Well, on the interfaces that touch the compute servers that we're using for our provider network, all we've identified here is switch port mode trunk. I'm using speed 1000 because I've got a 1 gig NIC attached to a 10 gig interface here, so I've adjusted that. But other than that, we've just simply got this switch port mode trunk, and then as we attach instances to our networks, we're actually going to see that our control server is going to log in using those Nexus credentials to go and modify this based upon the needs of OpenStack, all right? So the first example we're going to do is we're going to go through this using the quantum syntax. Then we're going to use the dashboard as a means to create a network and launch the instances as well, okay? So we're going to copy in our net create statement. So net create, I'm calling it VLAN 500, provider network type VLAN, that coincides with this tenant network type VLAN. Provider physical network FizNet1, that's the identifier that we are naming here and that we previously identified inside of our mappings, okay? And then segmentation ID 500, which in segmentation terms in the networking world is VLAN 500, okay? And so we're creating a network on VLAN 500. Then we need to associate a subnet create with this. And again, I'm just naming it. Very important element here, allocation pool. So just for a second here, when you're doing provider networks with VLANs, you've got upstream devices that are on those VLANs. Either they're trunks or they're SVI termination points, whatever the case might be. So you're already using addresses out of your range. So if you've got something like HSRP like we're using here, then you may have .2, .3, and a standby address of .1 that is being used as a default gateway. So you've already used 3 addresses out of that range. And you may be using other addresses for management addresses and so forth. So when you are using provider networks with VLANs, completely independent of the Nexus configuration, but just generically provider networks, you need to make sure that you're using an allocation pool that is starting and ending in a non-conflicting zone, right, where you've got addresses that are maybe used in the low order or maybe in the high order, and you're using something in the middle, and that's what we're using in our example, okay? Very important. If not, you'll start getting conflicting address entries on your logs on basically all of your nodes that have an address in that range. We're associating the subnet with VLAN 500, the network we just created. There's the network, and then I'm using a DNS server of this value, okay? Cool. So now if we come back out here and take a look at our network topology, we can see that we've got this. All right, so let's go launch an instance. I jumped over to this console to show you that we didn't have anything running before. There's, like no smoking mirrors and going on here. And then, so we're just going to launch a VM against that instance. Now, what we're going to see here is we're going to see a console entry pop up on this node. On our switch. So you can see here, configured by admin, remember our credentials, admin with the password from 10.121.1350, which is our control server, and it's doing it via the XML agent, okay? So now if we come back over here, we now see a new entry, switch port trunk allowed VLAN 500, right? That was the segmentation ID, and if we do a show of VLAN ID 500, we can see it also created an entry in our database, right? VLAN 500, this is what it named it. We had already had VLAN 500 via our trunk links, the 2 going to our AG, the 1/6, which is the interface going to our control server for the DHCP agent, and then 1/8, which it just now created. Okay? So now let's go back over and see that we've got a VM attached to that. Okay, so now let's go to the dashboard view and do this configuration via that method. It's important to identify that as an external network. Then we're going to go and create a subnet. Now, real quick, this is very important. The difference between the dashboard and the CLI, it can be profound. So when we built this original network, we identified segmentation ID 500. Well, what if I wanted to do 525? Well, I just do 525 and make sure that my networking is supportive of that VLAN, right? Not a big deal. So I can pick whatever I want to from a quantum command. When you do it via the dashboard, it always moves in numerical order. So it already knows there's a network created with the segmentation ID of 500, so it moves to 501, 502, 503, and so forth. So if you're training people to do these via the dashboard only, know that they're always going to be created, at least in the Grizzly release at this time frame. It's always going to be in numerical order for segmentation IDs. If you need to make them out of numerical order, then you need to be breaking them into the quantum command, at least for now. Okay, that may change in Havana, but for Grizzly, that is the case. So let's create our subnet. I can type rack today. And then modify our allocation pool. Okay. So we're going to do a create here, and that's good. Again, you'll notice that nothing has happened on the switch yet because we have not attached an instance to it. So we don't do anything really until we launch an instance. Okay, so let's create a new instance. And then we're going to attach it to 501, and we're going to launch, and then we'll actually see a modification happen again here via XML. And we can see now switch port trunk allowed VLAN 500 through 501 is there, and we can now see our VLAN entry in the database. Okay, so let's wrap this up. Now, the question is, okay, well, what happens on this console here if I am removing instances from those VLANs? What if I then want to reuse in a different project for a different application those same segmentation IDs later on? Well, what if I have some legacy configuration for this host in place? Well, it wouldn't be very dynamic or cloud-like if we left all of the configurations static, basically a kind of a one-time configuration and then never touch them again. We need to have kind of those CRUD type operations supportive in the Nexus, right? And so that's really what we're doing. We don't want to just create. We want to be able to read, update, delete, and so forth as our cloud environment changes. So what we're going to do here is we're going to delete the instances, one for each network, terminate those. We'll see down here on our console. Again, you can see that we've made changes for both of those networks. And we can take a look at our configuration, and now we've stripped those VLAN ranges out of there, okay? And so now we can start all over, or we can repurpose this, all right? So it's not just a one-time config. We're putting the setup there, and then we're never touching it again. We're actually being able to modify it as the needs of the OpenStack environment, specifically networking, change, okay? So wrapping this up, there's also a document out there that you can get from the docwiki.cisco.com website. You can take a look at the URL here. Just do a Google search or whatever your search engine is, and you'll be able to easily find this document that I've posted that kind of walks through all of what we just went through verbally and graphically. Okay, this is probably a less painful thing to go through than hearing me. And there's a little diagram associated with it, and installing the COI cache and build servers from scratch. Those instructions are there. as well as more example configurations of the manifest file. Again, you can see here in this example that we got multiple compute nodes with multiple Nexus switches with multiple credentials. So that gives you an example of how to do that in a larger environment. And then again, example of a top rack switch, basic stuff, and then the commands that we went through to identify your networks and subnets and so forth. Okay, so this document's a good auxiliary kind of thing to always bookmark and go to instead of just watching this video. But hopefully this video was helpful for you. Good luck in your deployment.